Hello and welcome to today's SQL Office Hours session. And we're going to be looking at data archival. So this is the process of moving old data and either deleting it permanently or moving it into archive tables. And the naive, simple way to do that is something like this. You'll just have insert into an archive table, selecting all the old rows, and then just delete them from a table. Pretty straightforward, fairly simple to write, but there's a problem. Running it can take a really long time. You know, these archival processes, you could easily be deleting hundreds of thousands or millions of rows. You know, even if you're doing it fairly frequently, like monthly, weekly, maybe even daily, depending on the size of your business and how much data they capture and grow, that delete process can take a really long time to actually execute. So the question here is like, how do we speed this up? How do we improve it? So we'll look at that today, but we'll also have some wider discussion around data archiving in general, why we do it, what it exists, and so on and so forth. So hi, everyone. I'm Chris Saxon. I'm part of Gerald Wenzel's developer advocate team and the answer team on Ask Tom. I'm here to help you get the best out of Oracle database and hopefully have some fun whilst doing so. So learn how to use SQL and PL SQL effectively. Now, before we kind of jump into the how, I think it's important to think about what we're doing and why. So when I'm talking about data archiving in this scenario, now, I'm meaning something very specific. We tend to overload terms a lot here in programming and software development. So what I'm saying here, this is the process of completely removing the oldest rows from a table, either just delete them permanently or at least move them from a particular, the transactional customer-facing tables. So for example, we've got our table here with rows for each year. We might delete everything that was created before 2020. And we're just doing a wholesale wipe and removal of it, either to move to, like say, other storage or just to delete it completely. And actually, something I was wondering, I've got a little poll. I was just wondering how many of you actually do this kind of data archival regularly, have some kind of process set up for it. So I've started a poll. If you could just spend a moment or two, kind of just yes or no, and let us know if you've actually got processes already in place where you're doing this, like on a, it could be daily, weekly, monthly, maybe yearly, you're actually going through and removing that oldest data. Okay, we've got quite a few answers coming in now, and it's a lot closer than I thought it might be, actually. So only a couple of people haven't answered, so I'll just finish up and share the results. So we can see it's actually roughly a 50-50 split, and slightly more people do have these processes in place than don't, which actually kind of surprised me. My experience has always been the opposite. People would like to do these kinds of things, but typically don't do them. So to start off, we'll look at kind of some of those reasons. Why do people not archive? Why do we not remove all this information? And the first reason is probably just kind of a bit of fear and scariness, right? Deleting data can be a little bit scary. Why? Well, because once you've committed it, that data is gone. What happens if it turns out you made a mistake, you deleted the wrong rows, you really needed to keep it for one reason or another? Getting it back can be a bit tricky and a bit fiddly. Now, Oracle database, we have things like flashback technology, which simplify this, but it can still be a bit painful, a bit of a faff. Even more so if you realize like many days or weeks after the fact that you really, really should have kept some data that you actually wanted. So, this is probably a big reason. It's just the fear, the uncertainty, the not really wanting to get rid of stuff. It applies just, with our normal stuff in our houses as well. I'm sure we've all got stuff, rooms full of junk that we kind of probably should get rid of, but can never quite really bring ourselves to. So there's that kind of fear aspect to it. But there's also, particularly in the era of big data these days, this idea that if we've got more data, it must be valuable. And if we just keep storing all the information, keep holding onto it, eventually we'll figure out some use for it. We'll find a way to monetize it. Either we can use it to help build machine learning algorithms, or we'll sell it to third parties. We're not really sure at the moment. Just the idea of we keep storing it, we keep holding on to it, maybe one day it will turn out to be valuable. It's a bit of a questionable assumption, right? So, but there are some people who kind of have this kind of approach or feeling about these things. So with these kind of reasons not to, it's important to take a step back and think about, well, why do we actually archive data, or why do we want to archive data, right? Why should we put procedures in place to do things like this? And probably one of the biggest ones, and the major one that might force your hand, is because you're required to. You might be subject to legal rules, maybe something like GDPR, data privacy, contractual obligations, company policies, that kind of thing. They might say that data older than X, we've got to get rid of, in which case it's kind of just a no-brainer, right? You will almost certainly, or hopefully, build these processes into the systems, if not from day one, certainly very, very early on. So that's helpful we need to do this in some situations. But there are various other situations where we'd kind of like to remove old data, but we haven't quite got around to it. So a big reason for that is cost. As much as storage is cheap, it's not zero, okay? And the more data we're storing, the more we're going to have to pay to actually keep it there. And this is one of those kind of creeping costs. The additional cost each day, week, or month for your storage is pretty small, or certainly a rounding error of the total cost of your storage. But if you're thinking about comparing, for example, 20 years worth of history versus just 2 years of worth of history, that's an order of magnitude difference. So that's a difference that can really, really add up if we're talking about wholesale removing of that old information, particularly when you start multiplying each gigabyte of production data up you've got by 3 or 4 times to account for things like disaster recovery sites, backups, pre-production QA environments, test environments, that kind of thing. So the space savings, certainly if you're significantly reducing the amount of storage data you're storing, the savings here can really start to mount up. And it might be that you're not actually just deleting the data completely. You might just be removing it from, like, say, the customer facing, the application attached tables to slower, cheaper storage, right? You've still got the data, but customers aren't going to be running queries against it directly. You're going to use it as part of your analytics or something like that. So you could save costs that way by moving it to different types of storage. So that kind of leads us on to another big reason why you might be looking at kind of data archival processes, and that is performance, right? Fact is, if you've got full scanning a 2 million row table is going to be substantially quicker than full scanning a 2 billion row table, right? So the smaller the tables are, the smaller the worst case for query performance gets, right? The just easier it is to manage. But it's also worth thinking about kind of back-end DBA type operations as well. We're not just talking about, queries in your application, maybe accidentally having a full table scan. It's also things, table maintenance operations, moving them to different table spaces. Perhaps more likely, more generally, things like creating an index. Again, creating an index on a 2 million row table is going to be a lot quicker than creating an index on a 2 billion row table. So there can be substantial performance reasons to archive the data. If not delete it completely, then at least remove it from the customer-facing transactional tables, which the application accesses regularly anyway. So that can be a big driver for doing this as well. So these are kind of probably the reasons you're familiar with. You're required to. There's laws or regulations in place you should or expect or need to follow, cost and performance. But it's worth thinking about the fact that having more data can itself be a liability as well, right? As I was saying before, some people think that let's just keep keeping all the data and eventually we'll figure out a way to make money out of it. Having data in itself can be a liability a business liability for reasons that are different from, you're needing to storage and performance and that kind of thing. There's a couple of reasons for this. One is something like we're thinking about data breaches. These days, all companies are going to targets of attacks. And to be honest, for most of us, for your company, it's probably not really a question of if you get hacked, it's more a question of when you get hacked. The more data you've got, the more you store, then likely the bigger the fallout from any data breach will be. It's more embarrassing for you as the company, potentially more embarrassing for your customers as well. Storing less information just reduces your risk from that perspective. But it's also worth thinking and bearing in mind that having information could be a liability to the business itself as well. I'll give an example of this. It's actually something that I kind of went through in a previous job. So here in the UK, we have got regulations for flight delays. So if your flight is delayed and it is the airline's fault, depending on how long the delay is and where you're flying and so on, you are entitled to compensation. And this compensation can be considerable, hundreds of pounds worth. So, it's certainly worth doing, putting these compensation requests in. Also here in the UK, we have got, under data protection, you are entitled to ask any company to give them all the information they hold on you, okay? And the maximum they can charge you is £10, right? So I previously worked for an airline. We start to see people kind of put in data protection requests and saying, here's my £10, please give me a list of all my bookings with you, all the flights that I've traveled on. So we have to comply with that. If we've got information about their booking, we have to send it back to them in a form they can use. They can then potentially reference that against a list of flights that have been known to be delayed. And it's potentially quite an easy way, get £10, it's a fairly small outlay for most people. You could potentially get yourself hundreds of pounds worth of compensation back. There were actually some companies who were kind of starting to set themselves up to do this. They'd do all the admin for you, pay the £10, and they'd split any compensation you got as a result of that. And as long as we stored people's full booking history as far back as it went, then we had to give them under data protection, right? So we were actually considering deleting that information, or at least delinking customers or passengers from the actual flights that they were on. So under, if a request came in, we could say, here, we just got your most recent information. That's all we have. So there could actually be good business reasons for not keeping and storing all this information. If you've got any others, if there's any other things that come to mind or reasons you have for archiving, the half of you that are, I'd love to hear them. Just let me know in the comments, right? So there are a lot of good reasons why we might want to or need to archive data. So let's kind of get back to the how now. Now, as we saw, very simple, naive way to do this. Let's assume we're not deleting it permanently. We're just moving it to an archive table. We just select the older data and then we run our delete statement. Now, the challenge with this is, as I said, that delete can easily be removing millions and millions of rows, right? I mean, depending on how frequently you run this and the size of your business and so on, that could be processing a lot of data. And delete is typically the slowest DML operation. That can take a really, really long time to run, potentially, even though that might be a relatively small fraction of the overall size of the table. Let's say, for example, you're keeping 10 years worth of history and you keep deleting off the oldest month. That's, less than 1% of the rows in the table, but it could still be a substantial number of rows. So what do we do here? How can we help improve the process? Now, I've talked a bit about delete in the past. We've got past recordings on that if you want to check them out. And if you join those, you probably remember, or you might know about, one of the tricks to make delete faster is to turn it into DDL. So rather than running the delete statement, what we do is we actually run some DDL to keep the rows we want and then swap things over. For example, we can do copy everything to a temporary table. Select the rows we want to keep, empty that table over, and then swap them back over somehow or another. Or even better, from 12.2, we had this filtered table move. You can move and add a where clause, and it will only move the rows affected by this process. So I'm not going to talk about these now in too much detail. A couple of reasons. As I said, I've talked about them before, but also these tend to only really help if you're deleting a significant fraction of the rows in your table. And now the question here is, what is significant? What's a significant fraction of the rows? Well, just to kind of illustrate here, I just did some basic tests. I had a 1,000,000 row table and I was removing 10% of the rows, so 100,000. And I compared various techniques: straightforward delete, 2 versions of create table as select, one where I switched the tables over, one where I kind of truncated and copied the data back, and a filter table move, and a truncate partition. The thing you notice here, the delete, plain delete, was kind of middling here. It was about similar performance to a filtered table move and a create table as select when we're swapping rows backwards and forth. So even though we're affecting a fair number of rows, those DDL delete operations only really help when we are removing quite a lot of the rows, or a significant fraction of the rows from the table. And as I said, typically when archiving, you're probably removing less than 5% of the rows of the table, probably, quite possibly, even less than 1% of the rows in the table. So you're in that awkward, sweet problem point where the delete takes a long time, but these DDL operations actually take even longer because you're still keeping the vast majority of the rows in the table. So, in many ways, it's a bit of a rock and a hard place. Although, of course, you notice there is one approach here, which is the absolute clear winner: truncate or drop partition. So this is where we have a partition table. And in this instance, all the rows I wanted to remove were in one partition. So 10% of the rows were in one partition. I just truncated that one thing. And that's basically pretty as close as you get to instant anyway. It's a DDL operation, metadata just resets everything. So that's really the technique we want to look at here when we are archiving data, is partitioning. So why don't we do this? Why don't we go down this approach? Well, there's a couple of important reasons. Probably the first and the biggest one is your table is not partitioned to start with, right? You start with your application, you build it on day one, you just create normal, regular tables. Over time, data volumes grow, and you get to that point where you'd kind of like to add partitioning to it. So, we've got the tables that are not partitioned at the moment, and we need to transition them. And there were a couple of challenges related to this. Firstly, and perhaps most importantly, important to remember, partitioning is an extra cost option, right? So if you have not got the partitioning license, then, don't just start going around here running these scripts. Make sure on your own databases, make sure you use XE or Oracle, the free Oracle Cloud, something like that, to try these things out. But there comes a point at a certain scale where you got to do that cost-benefit analysis. The benefits you get from partitioning massively outweigh any cost it has. So that's probably one reason why the table isn't partitioned. The second is actually, how do we add partitioning to an existing table? As I said, if you didn't design these archival processes to start with, chances are you've just got a regular table. How do we convert it? And this is something that was always a bit of a faff, shall we say, right? You could use DBMS redefinition to change the table and actually add partitioning to it. And over the years, this has improved. We've added procedures to do things like copy the indexes, constraints, triggers, and so on, and overall simplify this process. But it still was a bit of a faff, right? There was still a whole bunch of things that you needed to do here and make sure it all fit together and worked appropriately. Fortunately, as of 12.2, we did at last build this into the language itself. You can now do this with a single alter table statement. This allows you to add partitioning to a non-partition table. In 18C, we extended a bit further, so you can actually change the partitioning scheme as well. So if you've got partitioning, you want to add subpartitions, for example, or you want to change from range to hash or something like that, you could do that too. One thing to remember about all of these, you're either adding or changing the partitioning schemes. There isn't a unpartition a table method. If for some reason you decided you added partitioning, you decided you wanted to back that out, you didn't really want to do it, you'll have to go back to DBMS redefinition still. So this is really neat. We could just do a single alter table, mono add partitioning, nice way to actually add this to a table as we went along. So see a question, how far can one simulate partitioning using a set of tables held together with a view? Would partition and pruning work when querying a view using the pseudo partitioning key? It's a good question. And this is kind of like the poor man's partitioning, the DIY approach. So rather than partitioning a table, you create a table, sales 2019, sales 2020, sales 2021, or whatever granularity you want, for example, and then have a view over the top which just unions them all together. And I think the biggest drawback of this is it adds a lot of overhead and maintenance for your staff. You've got to make sure the processes are in the place to actually create the new tables, copy the information over, and so on and so forth. And unlike regular partitioning, if as you say, you don't get partitioning pruning because you haven't got the partitioning key. It could be that you're unioning together and combining lots of tables. So the answer is you can do it, but it is a lot of faff. And yes, partition pruning can help a bit, but it's just one of those kind of, how much effort are you willing to go to do this, right? Cost benefit analysis. Think about how much time and work it's actually giving you to do this. Okay, so I hope that answers your question. If not, just let me know. Okay, all right. Are interval partitions supported by Oracle text indexing? Not sure. Depends on what you mean by that. You can have Oracle text on partition tables, as far as I know. If you mean something different, then please let me know what it is you're looking for. Okay. All right, so thanks. Good questions, folks. So let's move on. We've added partitioning to a table, and then, as we said, if we want to remove the oldest data, it's nice and easy now. We can do a drop or truncate, and these are basically instantaneous. We can easily wipe out the oldest data from the table. Really, really cool. But as I was saying before at the start, quite often you want to remove that data from your customer-facing tables or the application-attached tables, but you don't necessarily want to remove it completely. You just like to move it to an archive table. You're like, yes, I still want to actually keep that information. So, how does this help me? Well, we could still do the insert select of a partition, copy it to the archive table, and then drop or truncate it. So that in itself would help significantly, because the insert, typically at least, is much quicker than that delete. But there's actually a better technique we can use. So one thing we might want to do is we'll create our archive table, and let's imagine we're day 0, or not day 0, we're 10 years down the line with our applications live, and we've decided we want to add archiving to it. So this is day 0 of the archiving process, right? We've got 10 years plus worth of history already. So we'll create our archive table, and we'll just copy it from whatever the main transactional table it is, using create table to select 101 equals 0, so that table is empty. Now, having done that, what we could then try and do, rather than doing an insert and then dropping the old partition off, is we can do partition exchange. And this essentially is metadata operation again, kind of just swaps the partition and that archive table over. So this is a great way to quickly move data into an older region or into a staging area. It's also particularly useful if you're doing the opposite. You're loading data into a staging area and you want to quickly swap it into your actual main table. So sounds great, right? Just got this nice alter table partitioning, exchange partition, and we'll get stuff back into the archive, right? Well, as I said, let's imagine this application's 10 plus years old. There's a good chance, or maybe not good, but a reasonable chance that when running this, you'll actually run into an error like this. It's like, what? We've got an error, column type or size mismatch in alter table exchange partition. And you're just like, table is the same, right? I created a copy of my production table using create table as select. It's got the same columns, right? What's going on here? Help me out. Why are these different? Well, over the lifetime of an application, there might be various things that you've done to kind of deprecate / remove columns from a table. For example, setting them unused, setting them to invisible, and so on. When you do that create table as select, these columns are hidden, so they don't appear in that query, so they're not in that target table. Okay, right? The two tables you're exchanging must have an identical structure, and that includes things like these hidden or invisible unused columns. And this was, again, typically a bit of a faff to deal with. If you got things like that, you had to dig through DBMS metadata and so on to find what all the hidden columns are, build them and copy them and create the appropriate clone. So again, in 12.2, we address this and simplified greatly with a create table for exchange command. So as it name probably implies, it creates the table we can copy the data to as an exact clone of our partition table. So now we've got an identical structure, including any of those invisible, dropped, unused, hidden columns, and so on and so forth. So we can build that table straight away. Thing to note about this is the table we create here, as it will say, we're cloning our partition table, but this table we're making is non-partitioned to start with. You can add the partitioning clauses here when we are creating our table. So you can say you've got your orders table, invoices, whatever it is. You want to create your orders archive, copy of it, and they both are partitioned by month, something like that. So we can do this, create our clone like that. So we could have our current table with the data in it and our archive table, which we've created for exchange and added the partition. At which point you might think, well, we can just swap the partitions over like this, right? Why don't we just try and do that? Well, sadly, again, this doesn't quite work. So to do an exchange partition, you're either exchanging a partition with a non-partition table or a sub-partition with a partition, right? You can't swap two partitions with each other like this. So, okay, so what do? How do we use partition exchange to move data from our active transactional table to that archive? Well, what we can do is create a staging table in the middle, a non-partitioned staging table. So we'll exchange first the staging table, I'll copy the data over, and then go from the staging table to the archive, exchange like that. So essentially, we do two exchange operations. So we swap it out to the historic archive like that. So pretty neat, nice way to actually quickly and easily move old data, either delete it completely or move it to an archive. So questions, comments on this at this point before we move on? I see there's a question come in. So I encountered the columns mismatch during exchange table in a slightly different way. There was a primary key over multiple columns. The columns originally were declared null. The primary key made them sort of not null. Yeah, that's true. It doesn't add the not null constraint immediately, does it? The create table select created the exchange table using the not null setting. Does the for exchange option also tackle this? It's a good question. I would have to double check. Like I say, the idea is it should be like for like, so it should work straight away. If it doesn't, then that's probably something we need to look at. But yeah, it's a nice little wrinkle there because primary key adds its own mandatoriness, but it's different to a not null constraint, right? We can try that later maybe if we've got time. but we'll see. Okay, how will bulk select insert compare to with respect to partition exchange in terms of performance? Right. Partition exchange is essentially instant. Okay, it's a metadata operation, so it is about as fast as you can get. Whereas select insert, I mean, how long does it take? How much data are you moving? It's, there's no simple answer to that. You've got to run it on your data and see how long it actually takes. So the answer is the crate for exchange is basically always pretty much a constant, which is almost zero. You can, if you need to update indexes and add validation and stuff, it might take a bit longer, but in general, it's much, much quicker. Does create table for exchange cover indexes as well? So there are various options for create table for exchange for adding the indexes. I forget all of them off the top of my head, but yes, you can look into making sure it maintains indexes and things like that. That is one area where perhaps it might take a bit longer if you've got global indexes and you need to keep those synchronized and so on and so forth as well. Okay, what is the best approach to continuously archive outdated data, for instance, when you need to implement data versioning for keeping track of data changes by users? Separate table maintained by triggers, or again, partitioning? I'm not sure. I think this is where if you've got like an is current record, and you've got the history of changes within it. Instead of basically doing it, I'm asking here is this what you're doing? Instead of actually doing an update, what you really do is insert a new row, set that to is current, or set the start and end dates on it or something like that. So you still got the full history. If that's what you're asking, then it's a bit of a different problem because it's typically more of a row by row approach. You're not kind of just wholesale deleting a whole bunch of information. You have to build it into that process. I mean, the ideal would be you've got some kind of API, you call that and it handles all the logic. Using triggers can help, just in case people bypass the API, but there's all sorts of ins and outs. So it's a bit of a different problem. Partition might help, but it not in the way I'm kind of really describing here at the moment. Okay. All right. And what about engineered systems? Can we use the same method? So the techniques I'm showing you here work on all enterprise edition of Oracle database. So if it's enterprise edition, you've got partitioning, you can do all of these things. So yeah, they work everywhere. They're in the SQL, part of Oracle SQL at least. Okay. Can we exchange partition towards HCC? HCC, hybrid columnar compression, is that what you mean? Do you mean something else? If you could clarify. Short answer is I think so, probably. I'd have to check, but I don't know. Yes. Okay, yeah. So again, like I say, you can, because you can set the settings in each table, and HC, it's not an area I know hugely familiar with, but you can have the settings on the table and you can adjust and run those. So how that affects the exchange and stuff, I'm not really sure. We'd have to check, but certainly at a principal level, it will still work in terms of how you can actually copy and exchange things over. If we want to have the archive table compressed, can we compress stage table before each exchange? Is that a valid approach? That's an interesting question. Hopefully we'll have some time. I'm going to do a bit of a demo later on. So hopefully I'll have some time to try some of these things out. So let's see when we get to that. All right. Okay. So as I say, we can use this partition exchange to kind of quickly and easily move data in or out of partition tables. And it will generally be substantially faster than delete and create and insert and things like that. However, as a few of you have kind of pointed out, we've overlooked probably one of the biggest reasons people don't start archiving processes, and that is parent-child relationships. What if we've got foreign keys that point to these tables. Resolving these can be a bit of a mess, okay? So, what do we do in this situation? How can we help ourselves out here so that if we need to remove data from the table? So let's look at, we've got our transaction header. That could be orders, maybe order item, orders, invoices, something like that. And then we've got the details. So very common: orders and order items, invoices to invoice items, maybe the customer themselves and to their orders and invoices, that kind of thing. Very common to have this kind of parent-child relationship. And what we want to do is we're going to try and archive off data from the header table. So we've got our orders, sales table, whatever you call it, and we're going to remove the oldest rows from it. And we want to, if we try and do that from the parent table, we do it with an alt table exchange partition, what's going to happen? We're going to get the error 2266 error because the foreign key reference is pointing to it, okay? So yeah, this is one problem here. This is one problem with this. It's how do we kind of cascade this operation to those child tables? So that's one issue. There's actually another issue with these as well. So we've got our parent and child tables, and we partition both of them, but how do we ensure that the rows, the partitions line up in them? So the row in the parent table points to a same partition in the child table. How do we make sure they stay in sync and they stay up to date? It's a bit of a fiddle. It's not the most straightforward thing to do. So in the past, we'd have to do something like this. We're going to archive off by date. So we'll have to have our insert date, order date, something like that in the table. And we'd also have to then copy that to the child table as well. So we've got a bit of extra overhead storing it. We'll have to add some extra validation, probably some extra constraints to make sure those values stay in the sync so that, the child has, for a particular order, it has the same insert date as the parent. Otherwise, you can end up, having them inserted into different partitions potentially. So we need to make sure those stay in sync. And then we've got to make sure that the partition definitions stay in sync as well. I mean, I'm being a bit silly here, a bit of a extreme example. Someone's completely screwed up the date for the partition for the child table here, set it back to last century. Maybe it's like test script that got overlooked or run on production by mistake or something. But making sure these stay in sync, it's the kind of thing they can easily get out of whack, particularly if you start doing things like partition splits or merges on the parent table or the child table. Very easy to do it on one and not the other, and then things all just get in a big mess, right? Well, there is a way out of this, and that is reference partitioning. So this is something we introduced back in 11G, I believe. And we've got our parent and child tables with a foreign key reference. And what we're doing is actually partitioning by the foreign key. So when, in effect, the child inherits the parent's partitioning scheme. They are a clone of each other. If you add a partition to the parent table, it will also get added to the child. If you remove a partition from the parent table, it will get removed from the child as well. For the purposes of archival and deletion, note we will need this on delete cascade option for the foreign key. It's not something you typically want, because typically you don't want to worry about deleting a row in your parent and a whole bunch of stuff disappearing on you. But in this case, we need it. Otherwise, we're not going to get the nice, simple functionality that we're really looking for here. So we can do this when creating tables, and you can also use do reference partitioning when adding it to an existing table as well. So as long as we've got that foreign key, you can alter table and add reference partitioning to it too. So what we can do, if we've done that, we can use this cascade option for the partition exchange. As the name might suggest, it cascades, it copies that operation to the child tables as well, okay? However, there is one thing to be aware of. It will only do it to one child of each parent. So what that means is if you've got a deep relationship, big chain of ancestry where you've got parent table with a child and a grandchild and a great grandchild and a great great grandchild. As long as each one of those only has one child, you're fine. And this will work. We can do that exchange and it will just swap them all out for you. However, as soon as you get into a situation where a parent has 2 or more children, this will no longer work. It's a limitation of how it works. So it doesn't resolve those references. So as long as you're in this nice little simple world on the left, it will work. If you've got a parent with multiple children and you want to cascade those exchange, that's where things start to get really quite messy. Okay. So, I hope that kind of answers the question about referential integrity. And this is comment about you may have several tables with more complicated cross-table business rules. Not just simple PKFK relationships must be satisfied for archiving specific rows, regardless of whether the topmost table is partitioned or not. I mean, thing is, if you've got business rules, business requirements and stuff, yes, remember here, what I'm very specifically talking about the wholesale removal of things. Certainly when it comes to stuff like GDPR, right to be forgotten, that kind of thing, you can be in the situation where you have to remove specific rows and resolve all the relationships there. That can be a very tricky problem to get around, right? And it's not so quite straightforward. Here I'm very specifically talking about, we've got data, anything older than this date, we want to remove from those tables. We're just going to remove, it's gone. Either delete completely or move it to archive tables. But it is a good point. You do need to bear that in mind. Okay, so let's copy those off. All right. So I'm not seeing any other questions or comments at this point. So kind of on that point where I was talking about archiving off specific rows. When I was announced this session, someone reached out to me on social media and said, well, what about in-database archiving, right? How does that affect things and how does that work? So for those of you who haven't heard of it, don't know, in-database archiving is a feature we added. We've got this row archival clause, which you can add to define when you're creating a table. You can alter table to add it. And then what that does is it adds this hidden or archive state column. So this is essentially an inbuilt soft delete. So, as I was saying before at the start, there's lots of reasons why we get nervous and don't like deleting data. Quite often, if we're talking about row by row deletions, a lot of applications take the approach like never delete anything. If we want to remove it, instead, you have an is deleted flag. Instead of deletes, you do an update, and then you have to propagate that through all your queries. So every query that only needs to see active data has to say, where is deleted is no, or whatever you've set that to, okay? This is a bit of a faff because, as I say, you have to apply it to pretty much every query in your database. You can simplify that a bit, either by creating a view over the top with the necessary where clause, or by using things like VPD, virtual private database. So yes, you can do that to do soft delete, but there's a lot of things to be aware of, a lot of things that can catch you out when you're doing that. With this in-database archiving, this is kind of transparent to the application. So we set this, all the rows affected by this update are now hidden by default. Okay, so if you run a select star against a table, they will not come back. You'll select with a no where clause, they are hidden by default. You can toggle a selection parameter to make them visible again. So this is to help solve the problem of soft deletes. We want to mark it for delete, hide it from general access, but still actually have it in the table. Lots of good reasons why you might want to do this. But as I said, this is kind of different to the archival process I'm talking about. Why? Well, let's think about what this does. When we're marking this for deletion, you still have the data, right? So if you've got legal whatever requirements which say you've got to remove it, you haven't met those. Just because it doesn't come back in a query doesn't mean it's gone. You've still got that data, right? You haven't saved yourself anything on storage because you've still got that data. You still need the space to store it. You haven't saved your costs there. What about performance? Well, I mean, there's things you can do here. You can partition on this column or create indexes to help. But fundamentally, you've still got the data. So it doesn't really aid performance by itself out of the box, right? So there are a lot of good reasons to doing this, but it solves a slightly different problem to the one I'm talking about. This is more about we've got some rows and we want to hide them from the application, but actually still have them accessible, you know, in case we made a mistake or there was some problem, that kind of thing, right? Is in database archiving separately licensed? I'm not sure. I don't think so, but I'd have to check. Always, whenever you've got licensing questions, check the Oracle licensing guide. That's always the best way. There's a section of the docs, licenses available or features available by edition, that kind of thing. Check that. That is the Bible. And if anything changes, that gets updated. So that's the place to look for any licensing questions. How does it affect the optimizer? It's the same way as an is deleted flag. It's the same concept. You know, you could roll your own and have an is deleted flag you set to 1 0 0. It's just a column which has essentially two values, yes or no, true or false, so on and so forth. So it would be the same process. But, you know, again, that's a big topic, kind of worms type of thing. Basically, think of it as an inbuilt is deleted flag. We don't need to run your own things. Okay. If you enter a new row with the same primary key, would it return dupe val on index? Yes. You're talking about these archive data. The answer is yes. As I said, the data is still in the table. Okay. It still exists. It's still consuming the storage. It's just hidden by default. It is a built into the database soft delete. So if you have clashes on primary unique keys, you're still going to have those. Okay. It doesn't solve those problems. It can help, but it doesn't solve those kind of problems. Okay. Alrighty then. Quite a few questions there. Okay. So that's kind of what I was going to talk, you know, the overview, things I was going to cover. As I said, I was going to have a demo and show how some of all this worked in practice. So let's go ahead and do that. So first up, I'm just going to create an orders table and my order items table. As I said, we've got the foreign key with the on delete cascade. So let's create that. Now, the first thing I'm going to do is deprecate this column by setting this unused, just to demonstrate the principle. So I'm going to add partitioning to the orders table. So let's add that in, and I'm going to add reference partitioning to the child table as well. So now we've got partitions in both those tables. So notice they've both got the initial P0. So this child table is copying the partitioning scheme from the parent. Okay, so we've partitioned those tables. I'll do the stage table with that deprecated column. I'll create my staging table, create table as select, and we try and do an exchange partition. And it's like, doesn't work because the type mismatch. That column we set unused is not in that temporary table we just created. So we cannot do the exchange. That fails. If we look in user tab cols, you see you get this lovely cryptically named column, which is the deprecated unused column, and it's hidden. So it doesn't appear in that create table as select. So the exchange fails. Right. So there was various other things which can mean that just doing a create as select didn't work and you couldn't do an exchange based off them. So let's drop the table and let's do this create table for exchange. And we'll do that. We'll create that. Oh, does create table for exchange cover indexes as well? I think, does it copy the indexes too? No, it doesn't copy the indexes. If you want to create indexes on this table, you'll need to do that yourself. You also need to copy things like primary primary keys, unique keys, foreign keys to those as well. As we'll see, I need to add the primary key and the foreign key to them. Okay, so those have not been copied. The column names, the data types, not null settings and so on, they are fine, but other types and constraints and indexes are not copied when you use this process. Okay, so we've created our tables. Let's put some data in. I'm just doing a small amount of data just to keep things quick. I know it may not show the purposes quite so well, but otherwise, I don't want to be sitting here 5 minutes waiting for some data to load or something like that. So now we've got our new partitions, and you can see it's interval partition, so we get those lovely sys partition name things. So start off with, we try and do an exchange partition. Now, as I said, these with interval partitionings, you get these auto-generated partition names, which can make some partition maintenance operations. It's much better to use this partition for syntax. Find the partition rows with this value are in. So I inserted sys_date. So that's I was partitioning by month. So we'll partition the current month. So let's just run that, and we see it doesn't work because of our foreign key references and so on. We add the cascade option, and then hey, it worked, and we've copied everything over. So order items is now empty, and it's moved to the staging table. Pretty cool, right? Pretty neat. So we moved it to the staging table. We actually want to move it to an archive table. So we need to then complete the chain. So let's create our archive table. As I said, we can add partitioning as part of create for exchange. So we'll do that. Now, in order to do reference partitioning, you need the foreign key, and we can't create the foreign key as part of this. So we'll have to do that separately. Okay, so we'll create our child archive table. We will add the primary key to it, add the foreign key, and now partition that as well. So now we've got our fully partitioned parent-child archive tables. Pretty cool. Okay, let's swap them over. Hey, there we go. Done, job done, and things have gone from the staging table to the archive. So as you saw, it had to be a two-step process. We had to go from the main transaction table to the staging table to the archive table, if that's what we want to do. Now, to kind of address how this actually works, how it's so fast, let's just look at the data dictionary here. And it's these object ID and data object IDs that we want to look at here. When we do partition exchange, really what the database, Oracle database does is it just swaps those pointers over. So it re-references things. And if we look at these, so we've got our orders and our object IDs and our data object IDs, you'll notice they have all cycled round now. So orders, object ID 918, that has now gone to orders archive, data object ID. We copied it from the stage to the stage and then to the archive. So the data has moved over. So notice those two values match there. We notice the other ones match up. 915 for stage matches orders, 931, right? Get the numbers right. For the archive matches those as well. So essentially we just cycled all those references around. This is how it can be so fast. It is not moving the data at all. It's just updating some pointers, okay? Okay, so we've done that. And now we might say we've moved it to the archive table. What we want to do is get rid of these partitions from the actual transactional tables. We don't need them anymore. We've archived the data off. So let's just check. We look at our partitions there. We've got, again, lovely sys partition names. We want to move this row, this one, and this one. Just do a drop partition. And again, we'll use partition for syntax. There we go. And they're gone. Hey, exactly. So we've managed to, we started with some normal tables. We added partitioning to them. We created a staging table using create for exchange to copy them over. We did the same for an archive table and added partitioning to that. And then we had our two-stage process to archive the data and finally actually remove it from the transaction tables. So hopefully you think that was nice and fun and fairly straightforward. All right, so we've got a minute or two before I wrap up. Any last couple of questions? We've talked about compression. Let's try that out. Let's see. Let's go back up here. The data is in there now. So we can just exchange it back. So the data is back in the staging. There we go. So we've compressed the staging table. It's not going to have much effect at this point because there's only like one row in there. If we try and swap it back in, and yeah, the exchange still works. So we were still able to do that. So certainly, obviously, in the real world thing, you have to look in a bit more details for how this works. Do you have a step-by-step procedure? The scripts are available. I've got a link, which I'm going to share with you in a second. So if you want to copy these and try them yourself, the scripts are available. Okay. Does the for exchange copy the deal with the not null thing? Let's just do an info. Let's just check these tables because I think I normally add all my not null constraints. Yeah, I added all my not null constraints. Or did I? Let's just see what it's done. It's added the not null constraint, but I did add that explicitly. No, maybe I think we'll have to have a fiddle around and try out, see how that actually works. Okay. Does partition exchange automatically rebuild the indexes? Well, something you might notice here, the index here is unusable. Okay. There is a clause, I'm pretty sure, to update the indexes. Let me try update indexes. There you go. Did that work? We'll find out in a second. I might have to rebuild them first, but you see there is an update indexes clause, so you can add that, and that may add some extra work to that process. So that's something to think about. Is it a good idea to have the archive data in a separate data? So is what can be some major issues. And again, I think this is one where it really comes down to why are you archiving? Why are you keeping the data, right? What is your goal in doing this? Let's say you want to keep the data for reporting purposes, there can be good reasons for moving all reporting to a separate database anyway. Okay, I mean that's many ways the architectural goal. Your customer application facing database literally only handles those transactional things, creating orders, that kind of stuff. All reporting is offloaded to the data warehouse or a separate reporting database. In that case, you've probably got some separate process for copying and doing all that. And your archival here is just a delete from production, the transactional database. And you've got your reporting elsewhere, possibly in some other data structures and things like that. So the answer is yes, but downside is it adds lots of complexity. You've got to have that process to copy the data over. What do you do if it fails? How do you recover? So on and so forth. So yes, it can be a good idea, but generally it adds work. It's probably the summary. Okay. Alrighty then. So just to kind of wrap up, because we're kind of past the hour, so let's finish up. So we looked at data archival, and here, as I said, we're talking about the wholesale removal of data older than a certain date. Why do we do this? Several reasons. Help reduce storage costs, improve performance, or at least limit the worst case for performance. And there might be business reasons for it as well. We need to comply with regulations. We want to stop any liabilities we might have from storing data we don't really need. How can we do it? Absolutely, the best way is partitioning. There's various reasons why you might want to partition a table, but data archiving is probably the real one that makes the biggest difference. Typically, once you get beyond a certain scale, deleting, archiving off huge volumes of data just gets really impractical, partitioning really is your friend for this one. Finally, we looked a bit at things like foreign key relationships, child rows, and so on. And ultimately, this always can be a bit messy. In the ideal scenario, you can use reference partitioning, where each parent has at most one child, and you can just cascade all the operations down. If you're not in that world, it does get a bit more of a mess, and you have to think more carefully about how you do these things. As I said, I do have some scripts available if you want to follow the demo I just did. You can get the scripts here. They're on LiveSQL, so you can download them. You can run them on LiveSQL itself. If you want to look more generally about how deletes actually work, I had that chart where I was doing performance comparison, compare that against various other thresholds for rows being deleted as well. So all that's left to say is I really hope you enjoyed this. More importantly, I hope you learned something. It's great to be here, and I hope to see you next time. Goodbye.